Okay, so let's go ahead and video homework number 3. Okay. Homework number 3 has a front and back side. Alrighty. First thing is they would like you to write the formulas for the ionic compounds here. Alright, so when we do that, we need to first know the oxidation number so we can crisscross them. So lithium is a metal, so it has a positive charge and it's in group 1 plus 1 charge. Oxygen is a non-metal, which is a negative charge, and it's in group 6 and it has a negative 2. And I'm going to go ahead and just write all of the charges first before I go any further. Aluminum is a metal, plus 3 charge. Chlorine is a non-metal, minus 1 charge. Sodium is a metal, plus 1 charge. Nitrate, which is a polyatomic, is a minus 1 charge. It's on your polyatomic chart. Chromium is a transition metal, and they indicate it with my Roman numeral numbers. It's going to be a plus 2 charge. Bromine is a minus 1 charge. Aluminum is a metal. Ammonium is a polyatomic, okay? And sulfur, which is a nonmetal. So polyatomic goes first. Look at the polyatomic chart. It's a minus 1 charge. Sulfur is a minus 2 charge. Silver is a transition metal, plus 1 charge. Phosphate is a polyatomic. It is a minus 3 charge. Magnesium is a metal, plus 2 charge. Carbonate, which is a polyatomic, is a minus 2 charge. Okay, now before I go any further, I need to know that we're talking about ionic compounds that are bonding together. What is special about ionic compounds when they bond together? We must reduce. And the only 1 and 2, no. 3 and 1, no. 1 and 1 is already reduced as far as it can go. 2 and 1, 1 and 2, 1 and 3, 2 and 2. So I'm going to come over here and I'm going to say reduce. So don't forget to reduce when we get to that one. Now let's come back over here. Let's crisscross them all. And when we crisscross it, Li2O. Let's keep going. This 1 comes to the aluminum. 3 goes to the chlorine. AlCl3. 1 and 1 is reduced as much as it could. Sodium, Na nitrate, which is a polyatomic, NO3. No parentheses because the 1 is going to come over when we crisscross it. 2 comes over here. 1 comes over here. Chromium, CrBr2. All right, let's keep going. Crisscross. Ammonium. Ammonium is a polyatomic, and the 2 is going to come over, so we're going to need to have those parentheses. So NH4, which is ammonium, parentheses 2, sulfur. Okay. The 3 comes over here to the silver. The 1 comes to the phosphate, which is a polyatomic. So since 1 is going over there, no parentheses. Silver is Ag3PO4. We are going to reduce. So let's reduce those. The 2 and 2 can be reduced to a 1 and a 1. Crisscross the 1 and 1. So since this 1 is coming to the polyatomic, no need for parentheses. Magnesium, MgCO3. Alrighty. Let's keep going. Now over here, they would like you to it says don't forget, or we already know, but in the pictures, if it has a Ca, that's indicating the central atom. The Ta is indicating the terminal atoms, which are the outside ones. Identify which of the following drawings on the left represents the compounds, okay, that are correct. Then identify the name of the shape, okay, and then they would like you to decide if it's polar or nonpolar. So first thing, deciding on if it's polar or nonpolar. How do I make that decision? Well, you can either, if you've got 2 atoms that are going to bond together, we can use our chart, our electromagnetic chart, and we can use that, do the subtraction, then go to that other chart, and we can decide whether it's going to be a covalent, polar covalent, or a polar compound. But, here's the but what overrides or supersedes that? Or if I have more than just two atoms that are going to bond together, how do I make that decision? I decide by looking at our drawing, okay, our molecular drawing, and we decide whether or not it's symmetrical. If I can draw a line straight through it and it's even on both sides, like identical, then that's going to be symmetrical and it's going to be a nonpolar. If it's asymmetrical, okay, especially if that Ca has lone pair of electrons, then it's probably going to be polar, okay? So let's go ahead and let's take a look. I have carbon and two oxygens. Now, just looking at that, my carbon is going to be, because carbon is always a Ca, and my oxygens are going to have to be TAs, the terminal atoms. So it definitely can't be A, can't be C. Those are only two. It can't be D. We got to have three, okay, because we have two oxygens and one carbon. So maybe B, maybe E. Obviously not E. Forgive me. That's 4. That's 4. So it can't be E. It can't be F. Right now, B is my only one that's an option. Can't be G. H is an option. Can't be J or K. So I'm down between B and H. Okay? So those are my only two that it could be. Well, let's come over here, and when we do our molecular shape drawings, we are going to go over here, and I'm going to put carbon, oxygen, and oxygen. I'm going to write down every single atom in this compound. 1 carbon and 2 oxygens. Then I'm going to go to the group number so I can see how many valence electrons, and I'm going to write that down. Carbon has 4 valence electrons, oxygen has 6 and 6. I'm going to add them all together. And in my molecular drawing, that is the magic number of electrons that are going to be in the drawing. Don't forget though, the drawing only indicates the valence electrons. Why doesn't it indicate the other electrons that are inside? Because there's more than just 5, 10, 14, 15, 16. There's more than just 16 electrons in this compound. The reason why it only has 16 is that's all that's going to be in the drawing and not every single electron is because remember those inside electrons has no significance. They're there, but they don't do any bonding. Who are the guys who do all the bonding where all the action takes place? The valence electrons. So that's the reason why we write them down. So now my magic number is 16. Okay? I can't have more than 16. I'm going to come over here and I'm going to do my drawing. Carbon is always a Ca. I'm going to do a line. Okay, why am I drawing a line? Because this is a covalent compound, nonmetal and nonmetal, and they share. How do I indicate sharing? With lines. Okay, I'm going to draw an oxygen and an oxygen. First thing, when we do drawings, we always try to draw everything symmetrical. Okay, if we have extra valence electrons, then we're going to probably, if we have to put them as lone pairs on the Ca, well, that's when my lone pairs shove and move those other electrons, those Ta electrons, out of the way. Okay, but first we try to do symmetrical drawings. Okay, so here's 2 electrons with that line and 2 electrons on that line. So 2 plus 2 is 4. So 16 take away 4 is 12 electrons left over. Okay. Well, carbon has to have 8 to be happy. Okay. So what is one thing that we do know about oxygen though? It's in our notes. If we're going to have an oxygen atom that's bonding with somebody, more than likely, not every time, and it's not a guarantee, but more than likely, it is going to have a double bond. Okay, now how do I know that it's going to have a double bond? Well, I can come over here and I can do the Lewis dot structure drawing. Okay, so for an example, carbon is in group 4, 1, 2, 3, 4, and oxygen's in group 16. The Lewis dot deals with all the valence. 1, 2, 3, 4, 5, 6. Oxygen 1, 2, 3, 4, 5, 6. What's going to happen is that this electron is going to share here, and this electron is going to bond and share here. this electron's going to bond and share here, and this electron's going to bond and share here. Do you see that? That shows me that that's why it's going to be a double bond. So if you're still confused on whether or not a double bond is going to occur or triple bond, do your Lewis dot structure drawing of all of those atoms together, and I can see how they're going to share here and they're going to share there. So this indicates a double bond, and those two indicate another double bond. So now carbon, let's count, because remember, every atom needs to reach the octet rule. Every atom is going to have 8, except for boron is 6, hydrogen is 2. Okay, those are my exceptions to the rules. So let's look at carbon. 2, 4, because each line represents 2. 6, 8. Okay, well, I used 4 over here, so now I'm using 4 more, so minus 4. So in this case now, I'm going to have 8 left over. I have 8 more electrons that I need to use. Can I add them anywhere on the carbon? No, I can't, because carbon has enough. Let's cover this up. Let me grab something over here, so that way we can cover it up. Let's cover up this everything else, and let's leave this oxygen. He's got a line here and a line here. This line represents 2, and this line represents 2. So 2 plus 2 is 4. He's not happy yet. He needs more. How many does he need? He needs 8. So 2, 4, 5, 6, 7, 8. Now he's happy. Cover this guy up. 2, 4, 5, 6, 7, 8. And let's look. 1, 2, 3, 4, 5, 6, 7, 8. Minus 8 equals 0. So now our numbers are good. Our drawing is good. Is this symmetrical? Let's see. Draw a line straight through it. Yes, it is. Who matches that? Is it B or H? H matches it. So I'm going to just mark that out. H. What is the name of this shape? If it's a straight line, we call it linear. And since I can draw a line straight through it, this is going to be nonpolar because it's completely symmetrical. Let's do this again. Okay. Nitrogen and chlorine. It's a covalent bond because nitrogen and chlorine are both going to be, or they're all nonmetals. First thing I need to do is I need to go ahead and add up. So I'm going to come over here. I'm going to, nitrogen has 5. Chlorine is in group 7, and there's 3. 1, 2, 3. 5, 10, 15, 20, 22, 24, 25, 26. So my magic number is 26. That is the number of valence electrons I need to use in my drawing. What else do I do? The next thing is I need to decide who is going to be my Ca. If I have one atom that's a lone one by himself, he's probably going to be the Ca. But if I'm not sure who my Ca is, it's going to be the atom that's further to the left, okay? Which in this case is going to be nitrogen. I have 3 chlorines, okay? So with the 3 chlorines, what do I want to do? I want it to be as symmetrical as possible. I want those Ta atoms, the terminal atoms, to be as far apart as possible. Why do I want that? Because those terminal atoms, they have electrons on them. And a negative and negative are going to try to repel each other. They don't want to get next to each other. They want as much space that, imagine, somebody's like, hey, you're in my bubble. Same thing here. This Ta is like, hey, you're in my bubble. Back up. Okay? And so they're going to try to spread out as far away as possible from each other. So let's do that. We have 3 chlorines. 1, 2, 3. They're going to try to spread out. Now, it's going to be a Cl, a Cl, and a Cl. Okay? So I use 2, 4, 6. So 26 take away 6 is 20. Okay. Now, nitrogen. Let's look at the Ca first because it's easier to go ahead and make sure that the Ca has all of his electrons, and then we can go look at the terminal atoms. But nitrogen has to abide by the octet rule, which means that he needs to have 8. He has 2, 4, 6. He needs 2 more. So for him to have 2 more, we're going to have to draw a lone pair of electrons over here. But when we draw those lone pair of electrons, it actually shoves the chlorine TAs out of the way. Those lone pair are stronger than anything else. And because they're stronger, they literally are like, they come in and they're like, hey, move out of my way. They physically push those other atoms out of the way. So now I have to redo my drawing because this is not going to cut it. So let me come over here and Cl, Cl, and lone pair. So 2, 4, 6, which we've already counted, 4 plus 2 more, equals 18. I have 18. I cannot add any more to the nitrogen because he has 8. That means those 18 must go to the chlorine. So 1, 2, 3, 4, 5, 6. Look at this, 7, 8. So he's happy. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Minus 18 equals 0. Which one over here matches it? Well, let's see. K. K has it. And yeah, it's not written 100% correct. It should look more like this. But K is going to be our correct answer. So let's scratch that out. And I'm incorrect. Look at all those electrons on the Cl. This one, letter K, doesn't have them. They don't have those electrons. E, I apologize. E is a correct answer. Okay, and there's a lone pair on the Ca. So E is the correct answer. What is the name of this shape right here? Okay, triangular, pyramidal. Could I draw a line straight through it? It doesn't matter if I can or not. If my Ca has a lone pair of electrons, automatically my molecular drawing or my molecular shape is a polar. Okay, that is going to override everything if your Ca has lone pair of electrons. Let's keep going. Boron and 3 chlorines. So boron is going to have 3 valence electrons. Chlorine is going to have 7. There are 3 of them. 7, 7, 7. 5, 10, 15, 16, 17, 18, 19, 20, 22, 24. 24 is the magic number. I need to use up 24 electrons. So let's go ahead and let's just start with our drawing over here, and then we can match it up. Well, I need to decide who is going to be my Ca. Again, boron is only a one single one, so he's pretty much going to be it, or the one that's closer to the, or one that's more left. So I'm going to put boron. What do I do with my drawing? I try to draw all of my Ta atoms as far away from each other as possible. So 1, 2, 3. Cl, Cl, Cl. Okay, let me just gonna there we go. Okay, now where's my boron? Oh, there, my Ca is my boron. Now we need to go ahead, and it's easier to look at your Ca to see if it needs any lone pair of electrons. Has it reached the octet rule? Well, remember, boron is an exception. He only needs 6 to be happy. Each line represents 2. So 2, 4, 6. He's happy. We're not going to add any more electrons to boron. So boron is going to be as good as it is. So 24 take away 6 equals, what's that? 18 left over. I have 18 electrons I need to use, and I cannot use any on the boron. So let's go ahead, and they have to go on the chlorines then. 1, 2, 3, 4, 5, 6. And plus that line makes it 8. So now he's happy. So 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Minus 18 equals 0. I'm good mathematic-wise. Let's come over here and let's decide which one is it going to match or look like it. The correct answer is going to be letter F. There are no lone pairs on the Ca. Everyone has all of their electrons. F is my correct answer. What is going to be the name of letter F? Letter F is going to be triangular planar. Oh, that's an N-A-R, sorry. Is it polar or non-polar? Well, remember, we have to go and look at our Ca. If our Ca has lone pair, automatically it's polar. Does it have lone pair? No, it does not. I can get a line right here and cut this completely in half, and this is a non-polar molecule. Okay, let's keep going. Carbon and chlorine. Carbon is 4. Chlorine is 7, and there's 4 of them. 1, 2, 3, 4. So let's add that up. 5, 10, 15, 10, 15, 24, 24, 26, 27, 28, 29, 30, 31, 32. All right, so 32 is my magic number. I'm going to come over here and just wipe this out just so I can get a little bit more space to do my drawing. Okay, so now I'm going to go ahead and do my drawing. If I have a carbon, that's a guarantee that your carbon is automatically going to be the Ca. Now I have 4 chlorines that are going to be attached to the carbon. How do I draw them? As symmetrical as possible. 1, 2, 3, 4. Chlorine, 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 chlorine. My carbon, because let's look at our Ca, must obtain the octet rule, which is 8. Each line represents as 2 electrons. So 2, 4, 6, 8. He's done. Do not add any more electrons to the carbon. So 32 take away 8 equals 24. Okay, so now let's go ahead and let's keep going. I've got 24 electrons to deal with, but I cannot add any to the carbon. So they're going to have to be added to the chlorine. And remember, the chlorines need to have 8. This chlorine only has 2. This chlorine only has 2. This chlorine only has 2. So they need 6. Every chlorine is going to need 6. So, and I got to reach 24. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Minus 24 equals 0. Bam, I am done. Now let's go ahead and look to see who is going to match this one. And actually, D matches our drawing that we did for our molecular drawing. So I'm going to put an X here, and this is going to be letter D. Now, what is the shape here? This shape is called tetrahedral. I'm going to, just so I can have a little more space, wipe that out, and tetrahedral. Can I draw a line and see if it's completely symmetrical? It is symmetrical, so it is nonpolar. Let's keep going. We've got another one. We have Cl, chlorine, and fluorine. So we've got 2, okay? Chlorine is in group 7. Fluorine is in group 7. So 7 plus 7 is 14. That's our magic number. So I'm going to have chlorine, and I'm going to have a line with fluorine. Why am I going to draw a line? Well, because chlorine and fluorine are both nonmetals, so that means it's covalent bonding. How do I indicate covalent bonding or sharing? With a line. So I already used 2 electrons, so minus 2 equals 12. Okay, now fluorine only has 2. He needs 6 more. Chlorine only has 2. He needs 6 more. So let's go ahead and draw those extra electrons that they all need. So that's 2, but he needs 6 more. 1, 2, 3, 4, 5, 6. He's happy. I've only used 6, so 12 take away 6 equals 6. chlorine now. 1, 2, 3, 4, 5, 6. 6 minus 6 equals 0. I'm done. No more electrons. Which one matches this? Do you see letter G matches my drawing? So G. Again, if I have a drawing that is a straight line, we call it linear. And I can absolutely draw a line right through it, and that makes it to be a nonpolar nonpolar molecule. Okay, this is homework number 3. It has a backside, so let's look at the backside here. Homework 3 is taking me a little bit longer to go through because it has so much drawings in it. But again, I think it's really good for you to look at all the drawings. Hopefully it would help you out to compare to your homework on how you did it. You know, that's what I'm hoping for. So the back side of homework 3, again, they would actually like us to do our drawings over here, and then they want us to name the shape polar or nonpolar. So really similar to the front side. What do I do when I do molecular shape drawings? Again, it's going to take a lot of practice over and over and over. So let's start with step 1. We're going to write the valence electrons for every atom in the molecule. Nitrogen is in group 5, so 5 valence electrons. Hydrogen's in group 1. There are 3 of them, so 1, 1, 1. 5 plus 3 equals 8. 8 is the magic number I'm going to have. Now, hydrogen can never be a Ca. There's only one nitrogen, so let's write him in. There's 3 hydrogens, and what do? We always try to have them as far apart as possible. So it would be hydrogen, hydrogen, hydrogen. Now the next step is to make sure that your Ca has the correct number of electrons, and they want to obtain what we call the octet rule. Nitrogen is not an exception, so he needs to have 8 to be happy. He has 2, 4, 6. Is he happy? No. He needs 2 more. Where are we going to put them? We're going to put them up there at the top. We call those lone pair. If we add a lone pair, they shove the Ta atoms out of the way. They're like, I don't know, they want to take up so much space. They're like, they hog up all the space. So I'm going to come over here because we need to draw it correctly. And I'm going to draw a line here and a line here. Hydrogen, hydrogen, and nitrogen needs 2 more. So now let's count up the electrons. 2, 4, 6, 8. 8 take away 8 is 0, no more. But don't forget, when you look at the hydrogens, hydrogen can only have 2, and that line represents 2. So he's happy, and he's happy. We're done. What is this shape? This shape is going to be triangular, pyramidal. Can I draw this? Well, I mean, I can draw a line through it and you can look at it and think, oh yeah, it is symmetrical. But what is the rule? If my Ca has a lone pair of electrons on it, it is automatically going to be a polar atom, or molecule, I'm sorry. Let's keep going. Boron and chlorine. Boron is 3, chlorine is 7. There's 3 of them, 7, 7. 5, 10, 15, 13. Sorry, 5, 10, 15 plus 3 is 18, 19, 20, 22, 24. So 24 is the magic number. Again, making our decision, the boron is going to be our Ca. He is automatically going to try to draw, we're going to try to draw our chlorines as far apart as possible. So Cl, Cl, Cl. Now, let's look at our central atom. Okay, they want to obtain what we call the octet rule, and boron and hydrogen are exceptions. Boron can only have 6, 2, 4, 6. Do not add any more electrons to the central atom. So 24 take away 6 is 18. Now the chlorines, if you look at them individually, this chlorine only has 2. So he needs 6 more electrons so he can be happy. The same thing with all of them. I need to use up 18 electrons. So let's do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Take away 18 equals 0. What is the name of this molecule here? Triangular planar. Oops. INAR. Draw a line smack down the middle. And my Ca does not have a lone pair of electrons. This is nonpolar. Let's keep going. 1 carbon and 4 hydrogens. Remember, carbons are guaranteed to be a Ca. So carbon has 4, and there's 4 hydrogens. They have 1 valence electron. 4 plus 4 is 8. Carbon is always the Ca. We want to draw everything as far apart and symmetrical as possible. Hydrogen, 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 hydrogen. 8 is my magic number. 2, 4, 6, 8. Take away 8 equals 0. I'm done. And don't forget that hydrogen can only have 2, and this line represents 2. So he's happy. What is the shape here? Tetrahedral. And this is going to be, draw a line smack down the center, nonpolar. Right? And the carbon does not have any lone pair of electrons. Let's keep going. Carbon and oxygen. Well, carbon's going to be the Ca. Let's write it down. Carbon has 4 valence electrons. Oxygen has 6 and 6. So 5, 10 plus 4 is 14, 15, 16. Okay? Carbon, line, oxygen, oxygen. Remember what I told you? Just a little hint. If I have oxygen, more than likely it's going to have a double bond. But to make sure it's going to have a double bond, let's draw the Lewis dot structure. Carbon has 4. Oxygen, 1, 2, 3, 4, 5, 6. Oxygen, 1, 2, 3, 4, 5, 6. This electron's going to bond here and share. This one's going to come over here. This one's going to come this way, and this one's going to come this way. 1, 2, look at those 2. Double bond. This is how I know that this is going to be a double bond. What's the next step? Go to your Ca. Does it have 8 electrons so it can meet the octet rule? 2, 4, 6, 8. Yes. Do not add any more electrons. So 16 take away 8 equals 8 left over. So since I have 8 more electrons I need to use up, and I cannot add any to the Ca, I have to add it to the oxygen. And just to show you, this oxygen only has 2, 4. He needs 4 more to equal 8. 1, 2, 3, 4. 1, 2, 3, 4.